Hello everyone, my name is Yusuke Matsui. Today I'd like to talk about a route guidance method for vehicles to improve drivers' experience delay against traffic congestion. In recent years, traffic congestion is one of the serious social problems. According to a study, the annual traffic congestion loss in Japan is about 40% of all. Also, the traffic congestion causes environmental problems. So reducing traffic congestions will be effective for improving economical and environmental problems. Currently, DRGS is researched as a measure to alleviate traffic congestion. DRGS is a system that obtains traffic information on roads in real time. Also, DRGS provides advised routes to vehicles to control traffic. The purpose of DRGS is reducing traveling time and reducing traffic congestion, and so on. Typical related works of DRGS use the k-shortest path algorithm to reduce traffic volume of congested point. The reason for using k-shortest path algorithm is not to concentrate vehicles on a particular path, and the strategy that deterring vehicles are located to very close to the congested point. In this way, they alleviate traffic congestion. However, related works don't directly take the increase of arrival delay optimization of each vehicle into account. In related works, vehicles located too close to congestion point are diverted. But there may be a better place than near traffic congestion. Please look at this figure. In point Y, driving on the detour increases arrival delay by 10 minutes. In point X, driving on the detour increases arrival delay by 5 minutes. In this case, the increase of arrival delay of point X is better than point Y. But related works select point Y as reload point. So, the strategy is the traveling time of all vehicles is not minimization. Also, related works don't directly take the capacity of data paths into account. So, these may cause heavy traffic on data paths. To solve the problem, our objective proposed total traveling time of all vehicles is minimization by considering the increase of arrival delay of each vehicle. Before I talk about the proposed method, I explain the system model for this study. It assumes that it is possible to obtain traffic information for all road segments from roadside units. RSUs and central server can communicate via the internet. RSUs and vehicles can communicate reliably. We will talk about our method with this premise. This is the overview of our method. First, we detect congestion load. Then, our method calculates the traffic volume to eliminate the traffic congestion. Next, we select intersections based on the increase of arrival delay for rerouting to alleviate the traffic congestion. Our method uses rerouting table to select the intersections. Thus, we provide vehicles with data paths at the selected intersections. I would like to talk specifically about the proposed method the following page. First, I talk about the method of detecting congestion load. When the ratio of the number of vehicles to the maximum number of vehicles on each road exceeds the threshold, the road is considered as congested road. For example, in case A, 2 vehicles are driven on road R. The ratio is 2/5 in case A. So, road R is considered as not congested road. On the other hand, case B, 4 vehicles are driven on road R. The ratio is 4/5 in case B. So road R is considered as congested road. After detecting congested road, we calculate how much traffic volume to eliminate the traffic congestion. The idea for eliminating traffic jam is to return to steady-state traffic volume from congestion state. Steady state means that there is no congestion in the target area. We compare the number of vehicles per unit time on congestion road with the traffic of steady state. The difference between them is the traffic volume that should be route guided. This beta is a parameter to express the growth of congestion and is a positive number greater than 1. After calculating the traffic volume to guide the detour, we select the intersection where a vehicle is guided to alternative route. We determine intersections for route guidance using rerouting table. The pairs of intersections applied to vehicles are selected in the ascending order of priority in the rerouting table to eliminate the congestion. The priority is determined by arrival delay. The method to select the pairs of intersection to apply from the rerouting table is as follows. Look at the condition. Left side is accumulation of detoured traffic volume. Alpha is the probability of the following route guidance. Right side is traffic volume to be reduced. For instance, assume that traffic volume to decrease is 70. If route guidance is applied at the pairs of intersection up to the third line in this table, the total of traffic volume to guide exceeds the traffic volume to be reduced. So the congestion will be eliminated by route guidance with third intersection pairs. After this, I will explain how to construct the rerouting table. The rerouting table is constructed by the following procedure. First, I explain step 1, calculating data path and arrival delay for all intersection pairs. As a preprocessing to build the rerouting table, the shortest path of all intersection pairs consisting of the source and the destination in the target area is calculated. Then, the pair of intersections including the congested road on the shortest path is obtained. Next, the data path is edge disjoint to shortest path is calculated. Here is the definition of arrival delay. The intersection pair added to the rerouting table fulfill the processing step A and B. Next, I explain step 2 and step 3. The intersection pair is extracted in the ascending order of the increase of arrival delay. Then, check the inclusion relationship between the shortest path of extracting the intersection pair and the intersection pairs already added to the rerouting table. Please look at this figure. In this figure, the intersection pair S' D is already added to the rerouting table. If route guidance is performed at the intersection pair S, D, the number of vehicles flowing into S' changes. In this case, route guidance cannot be performed based on the rerouting table. For this reason, if the extracted intersection pair fulfills this relationship, it is not to be processed and is extracted next intersection pair. Next, I explain step 4 to step 6. In this step, obtain the data allowable traffic volume in the steady state. We plan the traffic volume to flow to the data path and add it to the rerouting table. Then, the allowable traffic volume of intersection on the shortest path and the data path change, so update it. The traffic volume of the intersection on the shortest path will decrease, and that of the data path will increase. The above procedure is performed for all intersection pairs to build a rerouting table, and road guidance based on the routing table is provided for vehicles to reduce traffic congestion. Let's move on to evaluation. We use the traffic flow simulator, SUMO. The comparison was with the case without road guidance and 5 existing methods. Assuming that the target area is Osaka City, we evaluated the efficiency of mitigating traffic congestion by the proposed method. A traffic congestion occurred by restricting traffic at point X at a certain time. Vehicles are generated from the road edge at regular intervals, and the traffic volume is defined based on a survey. Next, the overview of the existing method will be explained. First, the traffic volume on each road is measured at regular intervals to detect congested roads. The method of congestion detection is the same as the proposed method. Next, we extract the vehicles that will guide the road. The conditions for vehicles that are subject to road guidance are vehicles that will enter the congested road, and vehicle to guide the road is determined based on L. L is the distance from the congested road based on the number of road segments. The vehicles traveling on these are the targets. In the interest of time, I will skip the details of each compared method. The setting values of parameters in the simulation are as follows. The values of K and L are parameters in existing methods. They are the best results from the preliminary experiments. The evaluation results and the setting are shown below. Let's move on to results. All the routing methods reduce the travel time compared to non-reroute, and it was confirmed that serious traffic congestion stays long without route guidance. However, the proportion of vehicles that received route guidance among all vehicles is low in all rerouting methods. Therefore, we refer to other figures for the effect of each method. The travel time for the vehicles that follow the data path by route guidance is compared. The proposed method is the smallest in the average and variance of travel time. This is the effect of the proposed method that computes the data plan in consideration with the arrival delay of each vehicle. We show the number of vehicles that changed the routes to the data. We see that all of the methods alleviated traffic congestion by bypassing almost the same number of vehicles. The following is a summary of the above. We confirm that each method is almost the same number of rerouting vehicles, and the proposed method has the smallest travel time for rerouting vehicles. In other words, the proposed method improves the effect of congestion on travel time. Finally, we conclude the work. In this work, we propose a method to reduce traveling time of all vehicles, and we show that our method is useful in the situation in which a road is congested due to a sudden accident. In future work, we would extend our method for multiple congestion cases, and we would conduct data planning using current traffic volume instead of steady state. That's all I have to say about this subject for now. Thank you for listening.